Hi everyone, welcome back to the workshop, and it's repair time again. And this time I've got a little Agilent U1731A. It's an LCR meter, handheld of course. And this one is a little bit tatty. It looks like it's been in the wars. Didn't come with any probes or nothing. It's just as it is. And on the back, it's even missing the actual battery cover and the tilting bail there. Yeah, and the screws, they look like they've been in and out a few times. Wow. Now I do have a battery handy. Not sure how good it is, but we'll give it a bash. And that goes in that way. And let's power it on. The bottom half of the LCD is not working. I can see very faint there. Some legends there, but there's basically nothing. Let me twist it, see if we get anything else. Nope, not really getting anything. Yeah, I think we'll need to open it up straight away, and I've got some ideas to what might be wrong. If it's using zebra strips to connect that LCD down onto the main board, perhaps they need a bit of a clean. So let's open it up and see if we can affect the repair. Oh, there we are inside the unit. And that does look pretty nice inside, I must say. Yeah, everything looks intact here. There's nothing burnt out or anything like that. So let's get the board out and let's take a look at that. I think I need to take off the screws on the back of the banana sockets there to get the board out, because these tabs look like they're soldered onto the board. And interestingly, this middle one's got a flat head screw, the other two got Phillips. I wonder if somebody's been in here before. And there we go inside the unit. It looks pretty nice inside. So 4 screws here to take off that cover there, and let's have a look at the LCD. Yep, zebra strips. Oh, wow. I think I see the problem straight away. And there's the problem. And the zebra strip is sort of pushed over at an angle. I think somebody's been in here before and not assembled it together very well. And this bottom zebra strip needs straightened out. And let's see if we can pull it apart. Well, the zebra strip's intact. It's not twisted, it's not bent. Sometimes rubber, if it's bent over at an angle for too long, then it kind of stays that way, but it doesn't look too bad. So I think I'll just put it straight in again. And there's it sitting nice and flat now. And I'll assemble it back to the board, and let's see if it's working. I'll try not to bend it over again at the same time. Oh, in fact, I think actually I'm going to take some IPA to those pads there. They look pretty dirty. Yeah, definitely needing a clean up. And perhaps I'll do the zebra strips as well. Right, just some IPA and a cotton bud. Should do the trick. If it doesn't, I might need to get the fiberglass pen out just very lightly. No, I think it could do with the actual fiberglass pen, just very lightly there. Let me grab that. Now you do have to be careful with fiberglass pens. It's really easy to take the top layer, especially in a gold plated board, but just very lightly. And then some IPA to lift the residue. That's looking a bit better now. And a little bit on this top side here of the actual zebra strip, just where it made contact with those gold pads. Yeah, you can see a little bit of dirt there, definitely on that zebra strip. I'll leave the other side because it's kind of sealed away. Right, let's try and put it back together. Get it the right way round. Hold it there and put the screws in. And there we go. Let me put it back into its housing. This could do with a clean up as well, but I'll do that once I get it working. Right, that's it back together again. I'll not put the screws in, I'll just put the battery in and see if it's working. Yes! Yes, we're getting that there. All the segments now. Yep, self-test. Yep, that's working there. Now, let's see if it actually works with a capacitor. 120 Hertz, and I'll put it down to capacitance. Well, that's not working. Nothing coming up. Auto mode's not picking up the capacitor at all. Nope, it's not working at all. Just nothing comes up on the readings down here. Not for any value capacitor that I put in it. So it looks like we need to go back inside it again. So maybe that's why somebody was in it previously and didn't put the LCD zebra strip back in properly. Well, we are actually moving forward now. There is actually a fuse in the board down here, but it's not a power input fuse. It looks like it's connected somehow, possibly to the actual bananas on the front. But if I take my thermal camera and looking down at some packages on the actual circuit board down here, absolutely burning hot. So something's drawing a lot of current. So I've hooked up my multimeter here, and let's take a look at the supply across some of those ICs. Here's a 4000 series, a 4052, and the supply across it is 2.6 volts and dropping. So something on this board is drawing a lot of current, and down on that package it was getting hot. I'm not sure what it is as yet. I think it's a regulator, maybe a 3.3. Perhaps that's the input, 5.3 volts. So I've looked at that package over there, it was getting hot, and I think that's a 3.3 volt regulator, because the far right hand pin does supply power to that 4052, and the left hand pin is common. So it's a different pin out than normal, so I think the middle pin is the input which goes to the tab, and I think that's the power supply input. So something on the board is pulling down that 3.3 volt rail, I reckon. I don't think the 3.3 volt regulator is faulty, although it could be. So let me get the thermal camera on again, and this time we'll scour around the board and see if I can see anything that's getting hot. Okay, that's power on now, and you can see the regulator down in there is getting hot. There's something over here. Looks like another transistor down there, a SOT23 I think. I'll need to check out what that is. But looking over the rest of the board, microprocessor down here, don't think it'll be that. Possibly some memory, I don't think it's that. A few other components are getting a little bit warm, but nothing like what's happening over in the corner here. Now perhaps that capacitor there Perhaps this capacitor here might be getting a little bit warm. Yes, it is. I think that's the problem. I think that 47 microfarad 25 volt capacitor is going a little bit short circuit. No, it's not across the output supply of that regulator. It's across the input of that regulator. Well, that doesn't really explain why the regulator is getting hot, but we'll change it out anyway. Right, let's put power on. There we go. And straight onto that 4000 series IC again. Nope, still 2.6. So I think that, yeah, that regulator's still getting hot. So quickly, onto it. Let's have a look and see what else is getting warm. Oh, I think I'll go around the board now. Let's see if I can find anything else that might be shorted out or something like that. You can see 52 ohms there. That's across that 3.3 volt supply. Well, I'm assuming it's a 3.3 volt supply. I haven't checked the code on the regulator. But yeah, I think 52 ohms does seem a bit low. Something somewhere on this board is pulling that down. So there's two packages. This one here and this one here are getting quite hot. Well, there's the two transistors removing the board. They've both got the same code, 2F. And if I just measure the resistance across those two pins there, it's basically open circuit. And that's fine. And that's fine as well. And this one here, if I go across those two pins there, look at that, there's my 56 ohms. Yeah, all three pins there are all shorted out together. So code 2F according to the markings on the top. Let me see what that is and I'll see if I've got a replacement. Well, I've found 8 2907s SOT23 package. Perfect. So I'll get them fitted. I'm going to replace both of those units there. I think one of them's definitely faulty, as you saw. The other one, not sure about, but it was getting hot as well. So it's probably been stressed. So I'll just replace them both. So I'll go ahead and do that now. Right, that's been replaced. Now, I did notice that the ones I've got are not SOT23. It's a slightly smaller package. However, I've managed to fit them on the board. They just fit onto the pads and no more, so we should be good to go. So let me put the cover on now and let's power it up and see where we get to. Right, here we go. Let's put the battery in. Not got the screws in again, just in case. So let's put power on. And we'll go for 120 Hertz and we'll go for manual operation. Let's put a capacitor in. I've got a couple here to try. Right, we started to get a readout there. Now we've got fuse being displayed, and that's telling me that the fuse is blowing. So let's take a look at the fuse. And the fuse is okay. So we've got some other problem with the unit now. Now what I think that might be, this unit may have a fuse detection circuit. And what that does is it can detect whether a fuse is blowing and send a signal to the microprocessor to display that message. Definitely seen that in some other units. So I suspect that's what this has got as well. So let's remove the fuse and let's have a look underneath that area of the circuit board. So here's the fuse here, I've removed it. We've got a capacitor there, we've got a 4052, we've got some resistors there, and we've got a FET, yep, Q1 right down there, really close to the fuse. So I'm going to probe that components, that capacitor anyways. Let's see what that's saying. And that FET. So going on the idea that maybe somebody reversed the battery or something like that, then it may have blown the fuse detection circuit. So I'm thinking that capacitor down there maybe, or that FET maybe more likely. So let me go and put my multimeter on there and let's see what those components are looking like. So try that capacitor first. Let's have a look at that. No, that's okay. Yeah, that resistor is 1K, that's okay. I'll try the FET. Won't be easy to get to. There's a lot of hardware around about it. Not easy on camera either. FET 1 ohm across 2 of the pins in that FET. Let me try another pin on that FET. Ah, dead short. Wow. That FET looks really suspect. I've got some diodes down here. Let me try them. Just the resistance anyway. Looking for shorts. Nah, that's okay. That one's okay. Let's try it in diode. Yeah, 0.5. Other way around. Oops. Yeah, that diode's okay. This one here. Other way around. Yep, that diode's okay as well. We've got another FET round here, or an SOT23 anyway. Don't know why I keep on saying FET. Across 2 of the pins, 1.5 ohms as well. Wow. Other pin. Yep, 1.5 ohms. Those two SOT23 packages look very suspect. So I'm going to take a look at the code on them and let's see if I've got any of them in stock. Back in a sec. Well, believe it or not, they're marked 2F as well. So they're 2907s. Great. I can go ahead and replace that too, at least get them off the circuit board and measure them, and let's see if the problem's with the circuit board or with the components themselves. So I'll come back once I've removed those two devices. Okay, both parts removed. Let's take a look. Yeah, 1 ohm, great. And the other one? Yes, 1 ohm. So those two are gone as well. Wow. I'll go away and replace those two and we'll see where that takes us. Well, here's an interesting observation. If you look at Q12 there, I've removed that transistor and Q11 down here, and you can see that on both cases 2 of the pins on that device are connected together. So they've been using those transistors as diodes. A very, very common way of reducing the BOM cost on the overall board. So even if I didn't have replacement 2907s, I could have just fitted a diode across there. But I've got 2907s in stock, so I'll just go and fit them. Right, diodes fitted, fuse inserted. Is this third time lucky? Oh, turn it off. Right, turn it on. Let's go for 120 Hz and let's insert the capacitor. Under test. Looking good. Yes! Yes! It's working! Hey! What size of capacitor is that? Oh, I don't even know. 1000 microfarad. Perfect. Yep, near enough 1000 microfarad. Just change the frequency. 1 kilohertz. Will it handle that? Yep. Oh, no, not quite. Too big a capacitor. Yes! How about this smaller one? What's this? 470K. Yep, 476 nanofarad. Perfect. 474 at 1 kilohertz. This is working. So as a bit of a recap, what was wrong? Well, this capacitor here was heating up. I don't think it was proximity effect to those two transistors because it was pretty warm to touch. So I replaced it with a 47 microfarad 35 volt. I didn't have a 25 volt one to hand. And the two transistors here, PNPs, they were shorted out. So I replaced them. They were loading up the output from this regulator here, which was flattening the battery rather quick. And a couple of transistors down here, same type as over here, 2907s. They were dead short as well, as I've shown. So how on earth that happened, I don't really know. I don't think it would be reverse polarity on the battery. I'm sure this has got reverse polarity detection on it. It could be that the DC jack on the front of the unit had maybe been reverse polarity there, or over voltage, something like that, and that maybe caused the problem. Not really sure. However, I've replaced 5 components and it appears to be back up and running. Well, just testing one of the other modes. I've plugged in an inductor, 22 microhenry, and it's coming up slightly low, but that'll be fine for these cheap and cheerful inductors. So it looks like it's working. And the cover didn't actually clean up as nice as I thought it would. It really needs a good old scrub, so I'll maybe do that off camera. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.